All right. Today we are going to do part 2 of lesson 3. So here are your warm-up questions. I will make them just a little bit smaller, maybe if my computer cooperates. There we go. Go ahead and take about 5 minutes to complete these. Pause this video. When you're done, come back and we'll go over them. All right. Now that you're done, there are 3 feet in each yard. Complete the table to show the number of feet in 1, 2, 3, and 4 yards. So we've got our table, number of yards, 1, 2, 3, 4. I know in my problem right here, it says number of feet in each yard. So each means 1. So for 1 yard, I have 3 feet. Well, now how do I get from 1 yards to 2 yards? Well, I just need to multiply. So 3 times 2 to figure out 2 yards is 6. I could also do 3 plus 3 is 6. So now for 3 yards, we're going to do 3 times 3, which is 9. I could do 3 plus 3 plus 3, which is 9. I could also take 2, or I could take the total yards in 2. Sorry, I had to think those words through. And do 6 plus 3 is 9, because I know this 6 here is 2 times 6. So if I add 3. Same for 4. I could do 3, oops, put my hand on my screen. 3 times 4, which is 12. I could do 3 plus 3 plus 3 plus 3, which is 12, or I could do 9 plus 3, which is 12. All are valid options. All right, number 2. Melanie is making lemonade and finds a recipe that calls for 1 part lemon juice, 2 parts sugar, and 8 parts water. She juices 2 lemons to obtain 6 tablespoons of lemon juice. How much sugar and water will she need to make the same ratio of ingredients as the recipe? All right, so we made our table. We have 1 part lemon juice. Notice it doesn't tell me a measurement. It just tells me part. So I could do any measurement. That's what it means when I say parts. I have 2 parts sugar and 8 parts water. So 2 lemons gave her 6 tablespoons of lemon juice. So I've filled that in my next column. How much sugar and water? So here's our question. Box, how much sugar and water will she need for the same ratio? So what that's asking is, what do I have to multiply this first column by to get to the second column? So what do I multiply 1 by to get to 6? Well, if I do 1 times 6, I get 6. So let's do 2 times 6. That gives me 12, because that's what I multiply. And then if I do 8 times 6, I get 48. Now, do we know that these are in the same ratio? If I write them out and I'm going to put how much we need to the parts, because when we want unit rates, we always want that 1 as the second number. So I have 6 tablespoons to 1 part, 12 tablespoons to 2 parts, and 48 tablespoons to 8 parts. So let's simplify. 6 to 1. 12 and 2 are both even numbers, so if I divide by 2, I get 6 to 1. 48 and 8, if I divide by 8, I get 6 to 1. I can always, to figure out my unit rate, always divide by this second number so that you can get it down to 1. So that is going to be the same ratio as the original recipe of the 1, 2 to 8. See, 1, 2, and 8. All right, so today we are going to continue working on recognizing proportional relationships between quantities, how we can determine those using a table, connections between ratios to represent a problem, explain the relationship. Our words, the one we're going to really work with today, we're going to work with proportional, which is 2 quantities are proportional if ratios comparing them are equivalent or equal. Non-proportional means they are not equivalent. And constant of proportionality is that the ratio value between two items that are in a proportional relationship. It has the same value as the unit rate. So example 1. Carrie earns $8.50 an hour babysitting. Is the amount she earns proportional to the number of hours she spends babysitting? Well, so we've got our table here. So for Monday, for 1 hour, $8.50 an hour, she's going to earn $8.50 an hour. Tuesday, we're going to figure this out just like we did in our examples. If I take $8.50, which is her 1 hour, she worked 2 hours, multiply it by 2, 16, 17, bring my 2 decimal points. So 2 hours is $17. $8.50 times, she now worked 3 hours on Thursday. 0, 15, carry the 1, 24, 25. So that's $25.50 that she got on Thursday. And Friday is $8.50 times 4 hours, which is 4, 20, carry the 2, 32, 33, 34. Oops, 0 times 4 is not 4. That's 0, $34. All right, so we want to know how much she spent. So if she worked 10 hours, I do, $8.50 times that 10 hours. My 0 can just come down. 1 times 0 is 0. 1 times 5 is 5. 1 times 8 is 8. 1, 2 decimal points, $85. So she should earn $85. So now it says find the unit rate. So let's write these out. It's going to be 1, or let's put the money first. 8, not time, it's money. So $8.50 to 1 hour. And then it's $17 to 2 hours. And $25.50 to 3 hours. 34 to 4, and 85 to 10. Okay. So let's simplify. 8.50 to 1 is still 8.50 to 1. $17, remember, divide by the second. $17 divided by 2 is $8.50 to 1. $25.50 divided by 3 becomes $8.50 to 1. 34 divided by 4 is $8.50 to 1. And $85 divided by 10 becomes $8.50 to 1. What pattern do you notice? So is the relationship proportional? Absolutely. All of my unit rates are the same. So how could she be paid an amount that would be non-proportional? Well, what if she babysat for 2 children and the first hour cost $5 more per extra kid. So rather than charging $8.50 for 1 kid, 2 kids would be, what is that, $13.50. 3 kids could be $18.50. And that's just for the first hour. And then, so this is 1 hour and the number of kids. So now then 2 hours, 1 kid would be $17. 2 would be add another $8.50. So 13, 8, 9, 10, 11 would be $21. $22 because I have to carry my 10. $18.50 for 3 hour or 3 kids would be, that's a 0, 9, $27. Those ratios aren't going to be the same. It's different. If we ever have to add something extra chances are it is a non-proportional relationship. Example number 2. A ticket agency charges a $6 service fee, there's an F there, on any order. Each ticket for a concert costs $25. Is the cost of an order proportional to the number of tickets ordered? So we know there's a $6 service fee and each ticket costs $25. So one ticket isn't going to cost me just $25 because I want to see the total order cost. It's going to be 25 plus 6, which is 31. So now what do I do? To find 2, well, I know that 2 tickets are going to be $25, which will give me 50, plus that $6 service fee is $56. 3 tickets will be $75, plus $6 is $81. And 4 tickets, not 24, 25 times 4 tickets is going to be $100 plus the $6 service fee, means it's $106. So let's look for our unit rate. So we start with $31 for 1 ticket, $56 to 2 tickets, $81 to 3 tickets, and $106 to 4 tickets. So 31 to 1, let's simplify. Divide by 1, nothing changes. 31 to 1, that's as simple as it gets. 56 to 2, I have to take 56 divided by 2. 2 goes into 5 twice. 2 times 2 is 4. 5 minus 4 is 1. Bring down my 6. 2 goes into 16 8 times. So we have 28 to 1 because 2 times 8 is 16, 0. Now we have 81 divided by how many tickets? 3. 3 goes into 8 twice. 2 times 3 is 6. 2, bring down the 1. 3 goes into 21 7 times. That's 0, so it's now 27 to 1. And our 106, we have to divide by 4 tickets. 4 goes into 10 twice. That's 8. 2, bring down the 6. 4 goes into 6 times. That's 24. So I have 2 left, so I have to add my decimal and a 0 to bring down. So now we have 20. 4 goes into 25 times. And we write money with double digits. So it is now 26.50 to 1. Are those unit rates proportional? Are they the same? 31 to 1, 28 to 1, 27 to 1, and 26.50 to 1. Is this proportional? No. So because the ratios between the quantities are not the same, the cost of an order is non-proportional to a number of tickets.